Hello! Today we're going to be looking at the distributive property. So we're going to start with a few examples here. We have 2 times the quantity x plus 5. So what that means is we have x plus 5 plus x plus 5, which would give us 2x's plus 10. And a simpler way of doing that might be to think 2 x's is 2x, and 2 groups of 5 would be 10. So these are equivalent to each other, as is this. So now I have 3x plus 12, 6x plus 6, 7x minus 21. Please note that for this one, I went ahead and said 7 times negative 3. Now, on this section here, we're going to do something called factoring. F-A-C-T-O-R. And what that means is you're going to rewrite the expression as a product of 2 factors. So, when I first begin thinking about this, I want to connect it to something I already know. So I already know how to simplify a fraction. So if I was thinking 5 and 30, what is a common factor they have? So I could divide each of those by 5 and get a whole number. So if I were to divide 5x by 5, I would get x. If I were to divide 30 by 5, I would get 6. And I can always check myself by working it out again. 5 times x is 5x, 5 times 6 is 30. So the greatest common factor of 8x and 8 would be 8. Then I could divide each of these terms by 8, which is my common factor. And this is my equivalent expression. All right. Next, I have 3x minus 12. So I'm going to factor out a 3. 3 times what gives me 3x? X. 3 times what gives me negative 12? Negative 4, or minus 4. Okay, 15 and 20. The greatest common factor is 5. So 15x divided by 5, it leaves me with 3x. 20 divided by 5 leaves me with 4. And again, you can always double check yourself by working these back out. 5 times 3x is 15x. 5 times 4 is 20. For the second section, we're going to do the same process where we are rewriting the expression as a product of 2 factors, also known as factoring. Okay, so I'm asking myself the question, what factor do 72 and 8 have in common? And that would be 8. 8 times what is 72? 8 times 9. And then there's a t there as well. Plus 8 times what is 8? That would be 1. 36 and 72, they have lots of factors in common. I'm going to select the largest one I can think of, which is 36. And then divide each of those by 36. Another equivalent expression, I think a lot of people notice 9 is a common factor. So 9 times what gives you 36z? 4z. 9 times what gives you 72? 8. So these are all 3 of these are the same quantity, but they look different. If you wrote them in standard form, each of these would be this. Okay, 3r plus 3s. So the greatest common factor here is 3. And I have r plus s, because 3r divided by 3 is r. 3s divided by 3 is s. So that's kind of where this comes from. Right. So here there are no common factors other than 1. So I'm just going to leave it as is. I guess I could factor out a 1. That's all that I can factor out. Okay, I'm thinking here. I know this divides by 12. So then thinking like that, let's see, if this divides by 12, 12 divides by 3, this also divides by 3. So that's just my thought process there. There are divisibility rules, and I will put a link for divisibility rules. So that you can review those if you would like. They're good to know if you don't. You should already know them, but if you don't, I will put a link on today's page for you. So 144 divided by 3. Just doing some long division here. Okay, so that would be 48Q. And then 15 divided by 3 is 5. Okay, the greatest common factor here is 4. 4 times 4x gives me 16x. 4 times 3 gives me 12. All right, on to the next page. So I love these diagrams here. It's a great way to factor things out if you're having trouble. So this is an array that we've dealt with before. I'll do a simple problem to remind you how this works. Let's say that we have 2 times 3. So here's how an array works. You would do the 2 here. See, that's separated into 2 sections. And maybe the 3 here. Now this is separated into 3 sections. So the answer is 6. Same principle we're going to use over here. I'm going to ask myself, what's the greatest common factor that these 3 terms have in common? And it would be 2. So then I divide each of these by 2. 2x divided by 2 is x. 12y divided by 2 is 6y. 8 divided by 2 is 4. And here is the expression that I could write. 2 times the quantity, x plus 6y plus 4. And an equivalent expression is right here, what's kind of inside this box, plus 12y plus 8. So taking it back here, you have 2 times 3, which is also equal to 6. And this was just an example from previous learning. And the 2 equivalent expressions modeled by the array would be 2 times the quantity, x plus 6y plus 4, and 2x plus 12y plus 8. So this array is just a way to organize and maybe even help you understand the process a little better. All right. Write the product of the sum of the expression being expressed in this array. So let's get this down. The first thing that we would need to determine is the greatest common factor. So I'm thinking maybe 3, but that doesn't work for 8. Maybe 4, but that doesn't work for 6. So maybe just 2. And that would give me 12D. 8e divided by 2 is 4e. 6 divided by 2 is 3. And I'm checking here. These do not have a common factor, so I think I've selected the greatest common factor. This would be 2 times the quantity. Make those parentheses a little larger. And then I'm just getting this from up here. Okay, and then the equivalent expression that is inside this box. You could also get this by multiplying this out. Okay, and now here's another question. It tells me to create an array. Again, this array is a way to help you organize. You can use it. You can always draw it on your paper if it's helpful for you. Okay, so the greatest common factor for these three terms, I'm thinking right away about 12. So I'm going to go with that. 48j divided by 12 is 12j. And I just get this because I know my multiplication facts. If you need help working on the greatest common factor, contact your teacher and they can help you with that. 24 divided by 12 is 2. So the factored version of this expression, it's equal to it, but it's factored. It looks a little different. 12 times the quantity with 4j plus 5k plus 2. Let's see how much more we have. I think I'm going to split this into 2 videos, and I'm going to go ahead and stop this first one right here.